to do this confirmatory factor analysis, we are firstly, of course, we need a model that is running, and we are trying to confirm that this model works, right? That's the main idea. Can this process also be done without a model? Like, I mean, for example, factor analysis, like exploratory factor analysis. After that, can we just confirm the factor analysis itself without a model? You know,
That's
I
a
mean,
good thing. That's
yeah.
I like that question. Now let's think about it. How could we confirm without the confirmation? What I showed here, which probably I was too fast, and that's what I really wanted to show in this part of this lecture, was that suppose you don't have a software to do confirmatory factor analysis. Suppose you have been given data and you say this is not this one, this is not confirmatory, the one we're doing. Suppose you have your set and you don't have a tool, and you've been told that this is a model. What I was trying to show you there is that we can take this, your own data, go to your own data, because you have been told that this is a factor model, isn't it? So you say, okay, I don't know where it's true. I go to my own data set, run my own data, and say, do I get that? So let's just use the data set that you have there, the same data set that has categorical variables. Is it this one? I think it must be this one. No, this one.
Yeah. What's the first step with this?
Yeah. So let's suppose this is the data set you have.
Yeah.
Okay. You don't have anything to do with you don't have confirmatory factor analysis. You have been given the data. Let's just take for granted that you have been given this set of variables, and you are told that this is a factor structure. Okay. But in your data, I'm just taking, so don't worry the fact that they're together, but in your data set, you've collected this set of variables which are corresponding, and you want to test whether where it's true. That's the question you're asking, isn't it? So you have this structure, and you collect your data like this, and you want to examine whether your data, your factor solution to this data set is like this.
Yeah, whether these variables can be, you know, refit into this model. Is that model like valid model?
Exactly. So that's what confirmatory factor analysis is doing. Confirmatory factor analysis says somebody has collected their data and they have obtained this structure. I use exactly the same tool, or whatever, a tool that gives me the same variables. And I want to confirm whether this structure applies to that data set or maybe a new population. So I take the same questionnaire. It was applied in North America. I take it to Europe. Then I say, is it valid for Europe?
Yeah.
Okay, so that's what our confirmatory factor analysis is doing. Because we are trying to establish a structure, if we are using confirmatory factor analysis, which assign F1 all these manifest variables. Say for F1, these are its manifest variables. For F2, these are its manifest variables. For F3, these are its manifest variables. And that's what we do when we define the model. So what you saw us doing in defining our model without the coefficients, the model. Let me close this and just open the model that you have. So the model is this one, isn't it? So we're generating data, so forget about that. So this is where we are now defining the model. Okay, so this is the model. So what is the model telling us? The model is saying factor 1 consists of this variable, not the coefficients. Factor 2 consists of these variables. It's going to estimate the coefficient. The first thing is that, is it true? Does this fit the data?
Yeah, okay.
Okay, so that's what it's doing there. But what I said to you was that, but you could also, which is a question I think you are asking, if I'll get you right. I'm using this data to test the same model. Okay, but I'm testing the model here, still using factor analysis, confirmatory factor analysis. That's what I'm doing here. Both of these data sets I'm using to test the model. But what if you didn't have confirmatory factor analysis, you wanted to test by any means? then you
Uh,
can just come here and do factor analysis, normal factor analysis, and see whether it produces the same factors as this model or not.
uh,
Okay, but you will not have any test statistics, you will not have any evaluation statistics. You will just use your own eye and examination to say, okay, I think my factors are the same.
okay.
Okay, so unfortunately here I've already created these variables as ordered. So you have to undo them so they are no longer ordered variables. I'm not too sure where is the function. It should be a function here to undo them. Okay. Does it do it?
Yeah,
Convert.
let's not worry about that. It's
Yeah.
just,
Yeah.
it's
So that is it. So what you do there is you take these same variables. I've done it as factors. That is the problem here. But if there are no factors, you just take these same variables. Okay. Actually, I know I could do. Yeah, it doesn't matter. I could take them from SPSS. So you take this variable now, you just do your factor analysis, and then you ask yourself, do I get the same factor structure?
right.
It's a weaker solution than confirmatory factor analysis, because in confirmatory factor analysis, you have those test statistics as well to say, is it a good fit?
Yep. Okay.
Okay. Did you have any, you remember you mentioned some data set. If you have any data set like what Uhu sent here, it really helped because she has a practical data set, and we can then show how do you translate the data set into what we're looking at there. See, I saw that yesterday. I said, oh, this is good because it makes sense. So we can then see what is happening there. We can use it to compare something that you can interpret. So if you have any model from your literature review that you think you want to use that to experiment what we've done, just do something like that. Send to me. I will give you advice on it. If
Yeah,
it's
thank
from literature review, don't worry that you don't have data because I can simulate some of the data. I can even put some noise on the data. This data that I simulated, I didn't put any noise on it, but it's easy to put noise on data. That's
I
why
see.
it's a perfect fit.
Yeah.
Okay. Yeah,
Yeah.
but when I simulate data, I would normally put some degree of noise that I put onto the data so that it's not a perfect fit. But I didn't do that here because I wanted to show us how the fit would look like. Then I thought during the class we'll put some noise, but the software is just it's a bit disappointing actually.
I see. So then I think the question is like she
Mm-hmm.
already had this model.
Mm-hmm.
But my question, I mean, like I always ask, I think the same kind of question, like I'm not that far yet. I
Mm-hmm.
don't have this model.
Mm-hmm.
So I was hoping by doing exploratory factor analysis can give me some idea of how I can create a model.
No, that's
Then,
correct. That is actually where you start. Confirmatory
yeah,
factor analysis is at a different stage. Most people don't go to confirmatory factor analysis. You only do confirmatory factor analysis if there's an existing model that you want
yep,
to confirm.
yeah.
If no existing model, then you are doing with principal components and factor analysis.
Okay, so okay, so let's say I have four variables. I just
Mm-hmm.
wanted to know by doing the factor analysis to see if there's a latent factor, right? That's the idea.
Exactly.
And I do it and I found maybe one or just two, latent
Mm-hmm.
factors that
Mm-hmm.
are significant enough.
Mm-hmm.
And well, with all the, the results and the coefficients.
Mm-hmm.
Then maybe within that, I come up with a model. For example, let's say A, B, C, D. I
Mm-hmm.
have that for variables.
Mm-hmm.
A causes B, B causes C. Simple.
Mm-hmm.
So B is the, the A, whatever that word is. Okay, so
Yeah.
A causes B, B causes C. And
Mm-hmm.
then there's D. D is somehow uncorrelated, but it kind of also causes C, for example, right? So
Mm-hmm.
that's a very simple model,
Mm-hmm.
which I don't even know if that makes sense at all, because only by
Oh.
factor analysis, I'm at a very, very early
Oh.
stage. I'm not
Mm-hmm.
even into this confirmatory
Yes.
stage at all. So that the reason I wasn't following that much was because I
Mm.
was thinking, okay, so I did this factor analysis, this
Mhm.
exploratory,
Mhm.
right? Very
Mhm.
early stage.
Mhm.
Can I do a confirmative factor analysis on this exploratory factor
Mhm.
analysis? I
Mhm.
don't have a model. Can I just
Mhm.
confirm my factor analysis?
Oh,
Is that possible?
yes, yes. I'm just thinking of what you are saying.
Yeah.
I'm thinking of what you are saying, because what will happen, I don't want to use simulated data anymore.
Yeah.
Well, I could just take one of the data sets we've used. Why not? So let's just take one of the data sets we've used here and see. Let's take our Canada banks, or maybe
Could you,
not.
if you go down, do you have food? Yeah.
Yes, yes. Let's take
The
this one.
food data, because I would just, okay, so let's say
Yeah, let's
we
take that.
have,
Let's see what happens to the food. Let's see which one we have.
yeah, and if we do a factor analysis first,
Okay,
please,
so
if you
so
could.
let's do factor analysis for 3 variables. So let's
Yeah, yeah,
suppose,
very simple. That's
yeah,
good
just three
idea.
variables.
Yep.
And then we want to use it in our model. So we'll come here and do factor analysis. I wish there were more, but okay.
Yeah,
So
let's
let's,
do very simple. Yeah, factor
yeah,
analysis.
okay.
If
So
we can do just like value, flavor, and energy.
value, flavor, um,
And energy,
and
because I think those three are,
yeah,
somehow related, but
yeah.
not
So what
close.
we're going to do is that we are going to use taste and this ones as variables, outcome and this, then this one is going to be a factor.
Okay.
Okay. So let's come here, and my hope is that at least one of them is going to be dropped out. That's my hope. Okay. So that
Okay, a
we don't use
screen
everything.
plot.
So everything else doesn't matter. We're just interested in the
A
rotation to see.
script plot, so we can
Yeah,
just
you
see
can use script plot to see where you
in the
script plot.
middle.
Yeah, yeah.
Yeah.
So this one we could save or could not save, but in the
Yeah,
history we
we
could save
don't.
it and use it.
Yeah, it's later. We don't
Yeah.
have to.
Just a nice straight line, eh? No drop. So the variables are all about the same magnitude. So you see that all three of them are being retained. Okay. So
The first one is retained, isn't it? So, I mean, it's above one.
I see what you mean. Okay, okay. Oh, you're right. It's one factor is retained. Yeah, sorry, it's one factor. But you see, but here there's no elbow. You see, in
Right.
when there's no elbow, there's no
Mhm.
justification. Well, I can use the justification of one of greater than one. Uh, but it's always going to, once one is greater than one, the other two are going to be less than one because the sum is three. So if you have four, remember that thing I was talking about degrees of freedom?
Ah,
You see why I plus here? Because I have all three variables. So when one is greater than one, the sum of the other two must be less than two. So neither of them can be greater than one.
right.
You see that? So
Right.
that's our concept of degree of freedom. You are trying to screen how many can you keep. I have three variables. One of them is greater than one. The other two must sum to to get any one greater than one. The other two must sum to a number greater than two.
Yeah.
Okay, but one is already
Okay.
greater than one. The sum of the three is three. So there's no way you can get another one greater than one. You see, that's why I have that perfect line here. That's that concept of degree of freedom. Remember, I was trying to explain to you how the degree of freedom come in.
Yep.
So this is a good example of that. You can only have a straight line here because there's really, it can, I mean, not straight. It's not going to be very far from a straight line. Okay. So do we have any changes? We have only one factor. In a case, it doesn't change the point. The point is that in our regression model, in our model, what you can do here is I am trying to predict. So let's write our model. Let's say food. Okay. And
Mhm.
food is equals to, I open that and I say, okay, I want to
Yep.
predict, say what two variables do we leave out? Taste. The two variables we didn't include were one. We have here flavor, value, and energy. So we have
Yeah.
taste and suitability.
Suitability. Yeah.
Yeah. So I come here and say, I like to copy very well, Sorry. So I like to copy because this thing just gives you so much headache that if you don't copy, it
Yep. I
gives,
know.
yeah.
Yeah.
And
Yep.
when you're alone, you can go on and on for something that is very simple. So I do head that. Okay. Then I want to take taste, or I want to do suitability as a to be predicted by taste. Okay. Now I'll also show you something. Remember, I said I like doing separate lines, so I don't like to do the same line. So I also say suitability is predicted by. So let's find a name for these common factors. Okay. We have value, flavor, and energy. Do you want to have a name for it? Okay, let me just say value, flavor, energy. Okay. So remember, value, flavor, energy is not in our data set, isn't it?
Yep.
So now, as one value, flavor, energy to be a latent variable. So I want it to be a latent variable, which means I have to put equals this, manifested by what? Those three variables that we just did. Value, flavor, and energy. We'll take the other one out.
Right. Yeah.
You see
Yep.
that?
Yep.
So in my model, I don't have this as individual variables. I have them as a manifest variable. So it's basically going to be doing this factor analysis and taking that factor and putting here. But you could do the factor analysis and bring the variable here. Okay, if you don't want to do all the intermediate testing to test whether they are significant or so on. So one can actually do that and just do the factor. We can do that just now. We'll do this one, then we'll do the factor analysis and replace it and see how similar the models are. Okay, which hopefully will answer your question. So if I do that, okay, then I say, okay, and I also wanted to look at this one on taste because I want it to be a mediator. Okay, value, flavor, energy on taste. Because this is what really makes sense.
Okay.
Yeah, and we can even put here A times this. Okay, this one if you want to compute the indirect effects, B times this, and suitability taste. I think this should be right. I will just say C and it doesn't really matter. Okay. So you want to compute this one, and here as well you want to see the coefficients and test. You can still put them there. Okay, just say A1, A2, but it doesn't matter. We are not really interested in that. We are happy with this. So let's run that.
Okay.
Okay. Then
yeah. Okay.
Then now we fit our model. So we'll say
okay.
So I'll just say food. Okay, I'll just say FD. Let me say food. This food model. Okay. Let me say food M for the model. And then this one I say food fit. Just
okay.
food fit. So I will know this is a fitted model. Equals to SEM. Then we take what? Our model from here. We take the model that we are fitting, comma, data equals to, what the name of our data set is here, food pref.
Is the food pref?
Yeah, right here, food pref. Where is it? My data equals to food pref. Okay, so hopefully it's not going to give us some ridiculous errors. Then I must remember to run this. Okay, and then I'll come and run this, and it should be fine. Great. So now we can summarize that model.
Okay, summarize it. All right.
Summary. Now we're summarizing the model. So remember that is the model we are summarizing. So it's the feed. Okay. Okay. So that's why it tells us. You see that? So from the factor analysis, this is the factor solution it gives us. Okay. Remember, it's standardized. So the first quotient is 1.
Yeah.
Okay. So that's why it's going to be slightly different from our rotation that we had up there. This is 1. This is 0.16, and this is 0.77. So it's going to be different because the standardization is like this, but it's tested it, and it's showing that indeed this factor is well explained by these variables. Okay, they are significantly related to factor 1 is well explained by the variables here. So this analysis that we didn't have up there, well, we technically had it anyway, but yes, they are well explained as a factor. Okay, they are correlated to it. You see what I mean? So extract factor 1 will be related to them. But this is significant, that's why it's telling us. And this one is more it's a stronger associated than this one. Okay, this one is not tested because we conditioned it not to be that. There's a way of telling not to do that anyway, but I didn't go through it. Now let's now come here and look at what is happening. Our suitability is being predicted on taste, significant, being predicted on that latent variable.
Yeah.
Not the individual variable, but the latent variable, which now we only do this to structural equation model. That's the beauty of it. It's good that you ask those questions, because they help one explain the concept sometimes better, so I see what is happening. The funny thing here is that the direct relationship between that and taste is not significant.
Okay. Okay.
Okay, that's the direct effect. We didn't compute the measures. Now we can go and compute them. We can come here and say, okay, give me the effects. So remember, our predictive model is suitability and taste. So direct, which is ST, we use this method equals to is A. Okay, so then we have indirect.
Someone is knocking on my door. I just need 1 minute, please.
Sure.
Yeah. Hi, I'm back. Sorry about
Oh,
that.
that's good. That's fine. I was just copying the graph plot to put there. So yeah, I just brought that. So the indirect now is from S to value to T. So I'm just putting it like this.
Okay.
So it's equals to. So we take the product from suitability. Where is that? Sorry, this is a direct. My apologies. No. Is this two? So from here to here, which is B, times from pace to this, which is C. Okay. So that's the indirect effect. And the total effect is just the product, it's just the sum of the direct plus the indirect.
Okay.
Yeah. So just the sum of the once you do this, you can always check to see on the diagram. So that's why I like plotting the diagram. So I see if I've done them correctly. And yeah. Okay. So let's run that. Then let's feed the model again. Okay. Let's see how it looks like now. So what we just added is at the bottom. So the direct effect. The direct effect should be there already because it was in our original model. ST, the original variable were they here. So you see that it's there. Remember, it was already in our model. So the direct effect is just a linear relation. It's the same thing here.
Okay.
You see? If you draw the graph, that was our direct effect because it was direct from suitability to taste. Suitability to taste. That was our direct effect. Our indirect effect was suitability, not suitability, was taste to VE, which is B, times VE to taste, which was C, product of the two. You see? C times this. So it's the product, and it's why it's being tested. It's not significant. Okay? The total effect is the sum of those. So the total effect is significant. Even though the indirect effect is not significant, the total effect is significant. Okay?
Oh, I see.
Yeah, the total effect is significant mainly because the direct effect is highly significant. You see, with a Z value of 14, but you see the level of significance here has dropped. You see, because the higher the Z, the higher the significance. So the level has dropped a lot. So the significance is not because the indirect effect is significant. The significance is because the total effect was highly significant. Okay, you see that. So I hope that this answer what you were doing. Now let's just plot the graph as our final thing. So again, we are plotting from the model. Yeah. Let's plot the graph here. Okay. So most of the time, just copy those things and use the one you like and plot. You don't need to spend too much time on them. So that is it. That's the model we've just fitted. So you have the direct effect from taste to suitability. This is the part that we did. but it's showing here that nothing is significant. Oh, okay. I think what I took, I only tested for significance among these variables. Okay, I did test significant among this one. So the graph that I did not test for significant on this side, test for significant on this side. I will show you why. So here I must say latent. I think here say latent, you see. You see here, it say here
Yeah,
latent. So that's
yeah.
why if I put regress here, I hope that I put regress here, then it should work. You see, now it's tested on the regression as well. You see, so it's tested that this one is
Oh,
significant. It's
oh.
tested that this one is significant, but this one is not. Because I said,
And the coefficients are how strong they are, right?
yeah,
The correlation coefficients, right?
yes, no, this one is testing yeah, the correlation, but in a regression sense.
Oh, okay, okay, okay.
Yeah, so it's testing
Yeah.
that the effect of taste, the direct effect of taste on suitability is highly significant. This is the regression coefficient.
Okay.
Okay, because on those parts they are showing regression coefficient, it's showing that the regression of VFE, this latent factor on taste,
Yeah.
is not significant
Okay.
because there's
Okay.
no star. But
Yep.
it's showing
Right.
us the regression of VEF, so suitability on this one is significant. So the lack of significance is because this one is no relation at all. So when you take this one time, this one becomes insignificant.
Huh. Right. Okay.
And then these are now the latent variables.
How about that one star
You
instead of
see,
three stars?
it, oh, me here. Oh, okay. It puts it says in the manual that 1 star means 0.05, 2 star means 0.01, and 3 star means
Oh.
0.001. Sorry, I forgot that.
Oh, okay.
Yeah.
Okay.
So this one means P is less than 0.05. This one means P is less than 0.001.
Ah, so yeah, so the one star is still significant.
Yeah, 1 star is still significant.
Okay,
Yeah.
I see.
Yeah, actually forgot. I forgot to notice in the notes. I even forgot that. I
I
forgot to
see.
say this in the notes. But please remember that when you see 3 star, it means that P is less than 0.001. When it is 1 star, it means that it's significant at 0.05. So P is less than 0.05. And then yeah.
Okay.
So for the question you said, this is exactly what you will get out of it. So what it means is that now this is helping us to do this regression, this factor analysis, as well as the regression.
I see. And okay, so let me just wrap
Mm,
up what this means, like the whole process. So this model here is after we've got because we only did, factor analysis on three variables,
yeah.
and we found that there's only one factor remained,
Mm,
one latent factor remained.
mm,
And we are trying to come up with a model like this.
mm.
And this is well, I
This
think
structural equation. This is a structural equation model.
yeah, the structural equation model. It's not the
Confirmatory
conformatory.
factor analysis.
It's not that
Yeah,
yet, right?
yeah. But the beauty about this is that it includes confirmatory factor analysis within the structural equation, because that's why it's testing this one. So this testing here is your confirmatory factor analysis that you are right to add this variable
Oh,
to say this variable manifests this one. This if this were
oh,
not significant, then you would say no, my confirmatory part of the model is not valid.
oh, okay, okay.
Yeah,
Kind of makes sense. Okay.
yeah. So you are actually combining confirmatory factor analysis in your structural equation modeling. Yeah, so
Ah,
that's now your level 3 of structural equation modeling. Is that within the structural equation modeling, you
yeah.
can add a model, a confirmatory factor model into that model. So that's why this is done. Okay. So
Okay.
if this coefficient were not
So
significant, if the coefficient that we saw they were not significant,
yeah.
then if I went in here and yeah, I like doing things that I shouldn't be doing. Sometimes I do too many things in the class. I want to generate the variable and add there, then just to show you that the variable would not be significant. When you have a package like this, you can do so many. I can come there and just generate a variable. Okay. Compute a new variable and maybe just random it from somewhere. want to take random numbers. Okay. Let's generate some normal random numbers and call the variable random. Okay, did it give me something? Oh, sorry. The variable is random. Is it even doing something here? So let's just call it random and add it there. What did I do? Okay. So normal 0, standard deviation 1, and it adds it to the full data. That's fine. So just run that. I'm not doing anything else. Okay, so that's just a random variable there. And what if I came in here and add that variable in my confirmatory part? Okay, where is it? Here, and I add random. Okay. So we know that this is a random variable, so it should not be associated with that, isn't it?
Right.
Yeah, because I've just generated a random variable, so there's no reason why I should associate with anything in there. So we come here and add that, and then we run that. Okay, and then we go and run our model.
All right. Okay.
Okay, that variable was purely random, so there's no way that it should be significant. If it's significant, then we have a problem.
Okay.
So you see here, it's not significant. You see that within the factor model, it's not significant, isn't it? Because we know it's a random variable. We just random variable. So there's no way you can tell that it's significant to this one. And indeed, it says it's not significant. So it's tested it and says it's not significant.
Okay, so sorry, just wait a second. Yeah, we because we already know when we created it's a random
A
thing.
random variable, so it should not be associated with anything.
Yeah. Yeah, so you mean then we can say it's not significant. Okay, so what is not significant? What
So this
relationship?
variable, you
Yeah.
see, in our factor analysis, we established that these are indeed this variable, or these variables are correlated enough and have a common correlation structure. So they are explained by one latent variable that we
Okay,
call
yeah.
this. Now we've brought this variable in, said all of these 4 variables are explained by one latent variable. That
Oh, okay, okay.
And this one says, sorry, no, I'm not being explained by that latent variable. Whatever is happening among these guys,
Oh,
I'm not included. I'm not part of that family.
I see.
Okay,
Ah, so this is not explained by the latent factor.
exactly. The latent factor does not explain the variability in this
Hmm,
one.
I
You see
see, I
that?
see. Yeah, yeah,
Yeah,
makes sense, yeah.
yeah. The latent factor does not explain the variable, which is that we expect it because we generated a random
Right.
variable.
Yeah, yeah, yeah,
Uh,
yeah.
so sometimes I say sometimes I do this, then I regret it because sometimes when it's a large class, some students get totally lost.
Right,
Because
yeah,
you're
yeah.
trying to demonstrate something, I think it's easy, but it's easy in your mind. It's not easy to the student.
Right.
Yeah, but that is exactly what we are doing. That the question you are asking me, tell me that no, this is a random variable. This is random on this data, nothing to do with this variable. So if it was significant here, I would say no, there's a problem with our model. It is not. You
Can
see?
you like plot the graph again,
Yeah,
maybe?
yeah. Let's do the
Okay,
graph
go on,
for
yeah.
sure, for sure. Remember that. Let's do the graph. Where are you, graph? So let's do
I
the graph.
think, yeah,
Yeah, here
probably this
is
one.
this line here. So it's there, and it's not significant.
Okay.
See that? So it's there, and it's not significant. Yeah. So that
Let's see. All
you
right.
see that?
Yeah.
Yeah. I think sometimes there's a model on education that say student-centered learning. I think the way you ask the question is really how why that model is very good. Is that when you are asking your questions, they help the teaching to be relevant. I mean, the way you
Hmm.
ask your questions, and it's always good like that. And that's why when Oho sent me her data, yes, I was so happy because it means my content is being driven by her questions. Like this one is being driven by what you're asking. You see?
Yeah.
And sometimes learning is better that way. Most of the time, learning is better that way. If you're able to ask the question and we'll go through and answer the questions,
Right. I agree. Yeah.
yeah. Otherwise, I enjoy mathematics, but playing the game does not impact knowledge. So it's good that you're asking and we are testing them. It's
I
really
see.
good.
Okay.
Yeah.
Actually, I have, the data collection I've been doing, it's still at its early stage. It's not
Mm-hmm.
much,
Mm-hmm.
but what I can do is having some of them
Mm.
make it a short database, like a
Mm.
4 variable, maybe each variable has 15 or like 12
Yeah.
samples, but still I can try to do something like this,
Yeah.
like factor analysis and
Yeah.
then
Yeah.
modeling
Yeah.
creation,
Yeah.
and well, I think,
Yeah.
okay, so next step, I think what I will do is to play with it
Mm,
and see what I can do and see what I'm confused with. And
mm.
then maybe probably next week or, and sometime, may I send you an
Yeah,
email
just
or
send something. Yeah, send something. Send an email. Sometimes it take me 2, 3 days to read the mail, but especially, but just send it and just have some patience if you don't see immediately. But once I see it, I will respond to it.
Sure, yeah, yeah.
Yeah.
I'll try to make it, clean and straightforward
Mm,
as I can. And
yeah.
maybe we
If
can
it's untidy, it doesn't matter if it's untidy, as long as clear in your head, in your mind. You see the way that I generated this data here.
yeah.
You can do this sort of generation as well. So,
Okay.
so what I'm doing here is that you see these numbers here are just from my head, eh? No, no, no. No.
Ah,
These numbers were from this one. This particular one were from here.
okay. Okay.
So if you are reading a literature in your area where
Mhm.
somebody has done this path and they create this, then just go and say, okay, I want to modify some of these coefficients here and put mine and see what happens.
The thing is, this study I'm doing, it's like really very, very few people are doing, and there is
Oh,
absolutely no model
is that right?
yet. So
Is that
I'm
right?
I'm
So
kind of
create a model
doing,
in your mind then. If you create
yeah,
a
yeah,
model, like you have what you see, the key thing that you want to remember is that in statistics, your variables are measuring and indicating sources of variation.
okay.
So if you take whatever you are trying to measure, you say, okay, what are those different things that can cause this thing to change? So
Uh,
just give me an example. You told me about your story. Just give me an example of what your main focus in the study is again.
to try to find out if some variable are predictive of other variables.
Mm-hmm. So example of a variable that you'll be interested in, that you
Uh,
will, the main variable that you're interested in that you want to predict, I'll
yeah.
call that
So,
variable an outcome.
okay.
Uh-huh.
Okay.
So what would be the most important outcome variable that you think you want to study, you want to start with?
Um,
So just something similar. It doesn't have to be. It could be like, for example, level of hearing or
yeah.
hearing ability.
Let's say binaural hearing.
Which one?
Oh, two-ear hearing.
Two-ear hearing or binary hearing. That's fine.
Yeah, binaural
Binary
hearing.
hear. So binary here. Let's just suppose, uh, in terms of scale of measurement, how will you collect the values? Is it
That's
is it a
in
machine you're going to use and hear the amount of vibration and say how much vibration am I getting to the ear, or is it the person responding to a question? Is it something that you can put in an instrument and determine, or is it something that you have to talk to the person then they answer back? So how would you?
uh yeah, so that's is a quite complex measurement, but
Yeah.
the outcome score is in dB. Like
Uh-huh.
higher dB means better, lower dB means you are not very good at the binaural
Oh,
hearing.
so it's so dB like in sound,
Yes.
like a measure of sound. Okay, that's good. So it's a frequency type of frequency. I mean
That's in
frequency in terms of physics, not in terms of whatever they call it. So it's like sound frequency, sound intensity.
yes, yes, exactly. Sound
Okay.
intensity. Yes.
So that means the range of values could, for example, be from theoretically from about what to what. Somebody who is totally deaf and can't hear, what would the value be?
Uh, they're not connected like that, but I
Okay.
can say a normative range would be, well, that's imaginary,
Hmm.
like from 0 to 10, let's say.
Exactly. So let's say from 0 to 10, and let's just say it's continuous scale. Okay.
Yes,
I
yes,
can even
yes.
say from 0 to 100, it's continuous scale.
Yeah, it's
So
continuous.
yeah, so that is very important. That potential range, but more important, this concept of continuous. Okay.
Yeah,
Then
yeah.
and then the question you are saying is that is it binary in the sense that uh is it on both ears or on one ear? Or are you measuring on each ear?
It's doing with 2 ears working together at the same time, and
Okay,
outcome is this one
one single
single,
measure.
yeah.
Okay. What happens if somebody is deaf on one ear? What will happen to this score?
That's another group. We are not yet focusing on that group yet.
Mm-hmm.
So we are only
So your
looking
measure
at,
is on this. Okay. What things could make two people have different values here?
okay, so let me give you an example. There's another test.
Mm-hmm.
We are imagining, what the hypothesis is that this measurement can predict this binaural. So it's called gap detection.
Mm-hmm.
gap detection
Mm-hmm.
measurement.
Mm-hmm.
So this one, the range can be from 0 to I think 100.
Mm.
Well, that's not precise, but
Yeah,
let's
no, but
just
that's okay because the data will tell you anyway. This
yeah,
range is
yeah,
theoretical range, but the data may tell you that is very different. So
yeah.
here it's also continuous.
Continuous, yes.
Okay.
Because that's in time, like
Mm,
0 to 100 milliseconds.
mm, mm,
That's a gap that you are trying to detect. Can
mm,
you hear there's a gap in between a sound? So that's the test.
mm,
So let's, well, it maybe there's no correlation, but let's say there is.
mm,
And so we're trying to see, okay, if
mm.
we can find a causal effect or something like that.
Exactly.
Yeah.
And
And
these ones are each of these done using different items. Like this different item was just a single measure that gets from the instrument.
two measurements.
So there are two measurements.
Yeah, two separate ones.
Okay. So let's say gap one and gap two. So gap manifest. Let's say gap one and gap two. Okay, because now you decide how to combine them, where you want to put them as separate or as one.
Ah, okay.
You see? So if I say gap detection, I'm saying there are two variables, and I say these are manifest variable, gap one and gap two. You see that?
Yeah,
So if there
yeah,
are two of them, I will say outcome one, outcome two. So that's the same idea. And we want to aggregate. So if you
yeah.
take other variables, which I don't know, maybe I would say height of the person, maybe where the person is standing or the height of the
Yeah,
person may
yeah,
matter, height in centimeters.
yeah.
Yeah, so maybe that may be another variable. So you add those variables, and these are all now your predictors. So if I have gap one and gap two as
Mm,
manifest variables, then in my model, I would say my outcome, binary here, okay. I'm doing a regression, so I'm going to predict it on gap detection,
mm,
okay. I'm going to predict on gap detection, okay. And I'm using the path, and that's why I see each path. Otherwise, we have written the model all that way, but I'm not writing the model that way. I
mm.
want to see each where you have a direct relationship. So this one, I want to put height as well. Okay.
Into the second one.
The
Yeah,
second one, but remember that this is like a multiple regression. So I'm saying that there's a path going from binary here to detection. There's a path going from binary here to this. There's
right.
also a path going from detection to
To
height.
hide. Yeah, yeah.
Okay. So now I'm going to put detection to height. Now, if I want to put like this, then detection has to already be computed. But I may choose to say I'm using the gap one and gap two and using factor analysis to estimate whether they together define this. And if they do, what are the weightings?
Mm, mm,
Well,
mm,
I don't know
mm.
the weightings yet. So I want the model to tell me the best weightings for them. So I will now come here and say, okay, I want my gap to be my latent variable, which is a function of gap one and gap two, is manifested by gap one and gap two.
Mm. Okay, okay.
So the whole model will do your basic model to say whether this indeed are related, are latent factors, which the correlation structure. This one, because there are only two variables, we just say yes anyway, unless the correlation was zero. Okay. This again,
Ah,
another thing where your degrees of freedom, or you say there are only two variables. If the correlation is not zero, it's all going to say they are factors. Okay.
ah.
Yeah, because if there are three variables, we say, okay, this one is not part of the two. But if there are only two people stand together, all do like friends. Unless you see them fighting, they say, okay, they are not friends. You see that? So that's what happens here. So the correlation has to be zero, which is like they are fighting for you to say
Mm.
they are not related. So because there are only two, but if you have more than two, that is good. Okay. So just remember that when there are only two, there's not too much that you are doing here. There's just
Yeah,
you
yeah,
can do
yeah.
it even manually. That's the thing to
Great.
remember.
Yeah, yeah.
So here now you put your model and say hearing model, here model, okay, and
Mm-hmm.
you have that, and you open your bracket. It's a different type of bracket. You have to open it in this one, and then you close it here. So that will be your here
Yeah.
model. Now, if you
Yeah.
didn't have data, you could actually come here and predict some, put some data values here to simulate.
Oh, right. Yeah. 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 I
See,
can
so
do that.
if you are trying to make some thinking, okay, what will happen? You take it to your data set and decide, okay, I don't have data for now. I'm going to do some simulations and see what it does. So here I'm going to say, okay, I end it here. And I'll just put the same model before the simulation so that when I simulate, I just run it. Okay. So this is model here, here, is here. The first one here will say here model, here data. Okay. I'll say here data, and they say I want to simulate the data. So you want to simulate, you can come here and say, okay, I think this component would, if it was a factor, this component would say it's one. If it is one, then this one should be, and you can put, I've not tried, but you can put a negative relation there. You can say this one is balancing this one.
Oh,
But for
okay.
now,
Yeah.
let
Yeah.
me just say it's plus, let me just say it's plus 0.75. So what it means is that this one has a greater impact than this one. Okay. So the one that has a greater impact, I give it one, just rotate it to one. So here, I'm saying this is about maybe 0. I tend to use decimals all the time, 65. So I'm trying to simulate a model for this. This is maybe 0.2. And maybe this is 0.7 or maybe 0.8. Doesn't matter. These are just numbers from my head. You can say where they come from, I don't know. It just come out.
Yeah. Yeah.
Okay.
Understood. Yeah.
Okay. So that would be the data, the model to generate the data. Then I already put the formula, the function for generating data down here. Okay, so I'll just take that one. All those other rounding are not that important. I've, for example, not constrained it to be between 0 and 10, but you can do that after you compute. And again, remember that this one is standardized data that is generating, not the actual scores. So it's generating this one on standardized data. If we want data that fits that model correctly, there's another way of doing it, which I've not shown you, but you don't need to worry about it. So this one is here data is a model. Okay. And I want to generate maybe 100 observations. I don't know why they put that L there. Okay.
Oh, okay.
So I will just call here sim. Here sim data. Just
In data. Okay.
yeah, just say simulated. So the important thing is that this is here. And if I run that, if it behaves itself, what did I do wrong? Or one of the things that happen with this is that when you copy it from edited software, it has some character that you don't see them.
Oh,
Yeah, that's minimize doing things in Word. It will have some character that you can't see them. And you can spend the whole day looking for those characters.
I see. Yeah.
Yeah, just minimize. Just type in. But that's why it's complaining here. So it's complaining about model something something, some strange character that is seen that we can't see. So let me see here that. Come on. Then samples.
Is it explaining? I don't think it's
No,
ex
can't see where it's complaining. It's saying and here. See, it's saying that there's a character before here sim. I can't see it.
Ah, right.
Yeah,
So
it sees something before here sim and even here model. I can see them.
yeah, /n means
Mm,
means something. Yeah.
yeah.
Um. Yeah, that's when you copy from
Exactly. Let me
yeah.
see here model. Let me see. Sorry. Yeah. This one is no longer complaining. Here, sim data. See. But I copied it from down there, so it shouldn't be a problem.
Mm. Oh, perhaps
Oh, you see something? No, sorry. This one
yes,
is yeah.
yeah. You need one from
Yeah.
there.
Let me
Yeah,
just
yeah,
put
just put yeah, good
yeah, let
idea.
me
Just
just put them here, isn't it?
in between, yeah, and delete this one.
Let's see.
Yes. Yeah.
Let's see if that works.
So that yeah, so that it was yellow,
Let's,
which means it's inside.
still something not right. Oh, sorry. Equals to. There must be an
Okay.
equals to there. Yeah, sorry.
Yeah, okay, I'll say it works now.
During the deletion, I deleted equals to during the whole process.
Ah.
Hear me.
Okay.
Yeah.
And
So
then
it's provided
there.
some data for us. We could just run that data. I would not even worry about all of those things. So now this is a model we want to fit on that data. Okay, you want to test.
Oh, okay,
But
okay.
this that's simulated data. So we could go and add some noise there, but for now, let's just run that model.
Yeah.
Okay. Here
Yeah, equals to.
equals to. We're going to go through the same process.
Yeah.
The
There
noise,
it is.
yeah, the dictation is very poor. The error dictation is very poor.
Yeah.
Uh, the error dictation is very poor. So I'm just copying those. I don't need to do anything. Okay, so the model is this one,
Yes.
and the data are this one.
Right.
And say
Bit
fit.
cat.
Yeah,
No,
no, just a fit here.
okay.
Yeah, and fit here. They just name that I want to remember. It's not really important because it's up
Oh,
to
okay.
you. It's up to you how you want to name your pet, how you want to name
Ah,
anything
I
you
see.
like.
Yeah.
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 So
And
let's see why
summary.
this one tells us. Okay. So this here will be significant because we generated them. Okay, because it's simulated. So again, because it's simulated, even the height is simulated. Remember that this variable in standardized format, so there's no problem. And there's no surprise significant. See this coefficient 0.7, this very similar to what we specified.
Oh, you mean what you just wrote down?
Yeah.
Okay.
So this
Yeah.
is a very similar because we standardize. No, not this one. Where's the model? The model itself. Where do we write the model?
Down there. Yeah, in the middle here.
Yeah.
No?
Yeah, here, there's one there. No. Gap detection, where is it? What has simulated the data binary here? Okay, it's up here. It's here.
Yeah,
You
yeah.
see? 0.75,
Right.
we have 0.78.
Ah,
Yeah.
okay.
0.75, have 0.78 because that's the path for simulation. What about this one? Binary here with gap detection is 0.71. No. Binary here with gap detection is here. 0.65, estimated
Hmm.
0.71.
Hmm.
Height is estimated 0.2, is given estimated point this one. Then height, gap detection with height is 0.8, it's 0.85. See that?
Yep.
So those coefficients are, because these are simulated ones, so when it simulates, they're not exactly the same, but they are very close. So you see how the parameters that we set here are here. And because they are simulated, they are being tested. But it says height is not related to gap
It's not
detection.
right. It's not.
And I think because of the value that we stated was 0.2, so when it simulates, the standard error shows that it's not significant. So if we
Okay.
took it to maybe 0.6, suddenly it will become significant. You see that? So you want it not to be significant, put small values to it. That's basically what he's saying.
I
Okay.
see.
So it taking this value and it simulates the values and find that you can get up to negative values based on that standard error. And it's not significant because what this approximately is about, if you take this divided by this, that's what it's estimating. So that's it. Now we come down here. So this is the test of your, this is really, the relationship is very weak, you put the low coefficient. The relationship is very strong, you put the large coefficient. And because the data simulator are standardized, so that means that the range is from -1 to +1. Okay. Now you can, if you wanted to, yeah, so you want to plot the graph. I think for you, the most important thing is to see the graph that you are talking about.
Oh,
And
yeah.
then that should be it. So let me go and copy the graph. There are many graphs. There's one that I say from left to right. I tend to like that one as well. R is not there.
Is it the same one as we used in
All
the
of them
in
are
the
all of them are similar, just the direction that I want to specify.
Oh, okay.
It doesn't really matter. I will just take one of them. There are many in here from that distance that they have pasted many, so that you try them out and see the one you like.
Oh, okay.
I want the one that says both latent and regress, so that we have them on the graph. Where is it? Regress. Where is it? I want the one that have latent and regress on it. The one that we used last time.
Yeah, in on
Okay,
the
it's here.
top. Yeah.
It's here.
Yeah,
Yeah.
here.
I just want that one.
Latent and regress. Yeah.
Yeah. Um,
Down, down, down.
yeah.
Up.
Down here.
Right.
Here. Now put say here. I'm not happy where this thing goes to, so there is also something that that's okay. Okay. So that is how your path looks like.
Oh.
So height is not the predictor of binary hearing. Gap detection is a no, height is a predictor of gap detection. That doesn't make any meaning anyway. But then gap detection is a predictor of binary hearing.
Yeah.
And the two gap factors, because there are only two, so we're not surprised anyway. Okay. And then you can do what we're doing, which is the effects, the direct and indirect effects. The effect that you're thinking about, if we're predicting from high to, I added this one anyway. We're predicting from high to, if high was an important variable and you were doing a prediction, then this is a direct effect, this is an indirect effect.
Yeah, so the direct effect is not
but I think
significant, but the indirect is significant.
Yeah.
Right?
But what we're thinking about gap as a determinant of this. So this is not exactly the model we're thinking of. You see that this is not the model. We wanted to say gap is a dictator, but maybe it's mediated by height, not this one. So this model is the wrong model from the way you explain. So how do we get the right model? Go back here. The model we are really interested in, you see, the one that's in the middle is gap detection. Say it's on both sides. Because we say that the endogenous variable appears on both sides. It appears as a predictor and an outcome.
An outcome, yeah.
Yeah, so that is always where your endogenous variables are. So anything that you see in the middle, let me go here. So when you see something in the middle, it means that it must appear on both sides of your equation. So these two are in the middle. So these are endogenous variables. They must appear as predictors and outcomes in your model. Only these two. This one can, okay, these two as well, because you see this one, there's an arrow from here to here. So if this one is in the model, then this one will also be an endogenous variable as a consequence of this. If this one is in model, this one will also be an endogenous variable. You see that?
Okay.
So, but if we are just taking from here to here, let's suppose we are just focused on interpersonal, then these two have arrows leaving them into interpersonal. So therefore, they're endogenous and they must appear on both sides of the equation. So that's the way you think about your model. If I
Okay.
come here, we're thinking about height, even though it doesn't seem to be logical, but we're thinking about height being the one that is on the other side, not gap. So here, just see what will happen when we interchange the two of them.
Oh, yeah. Reverse them. Yeah.
Yeah.
Yeah,
So
good idea.
so when we reverse them, you will now see the interesting thing that
Mm.
okay, then I feed the model. Then I'm interested now in the plot. So now you see that you are going from gap detection to your height to this one, which is the model that you are conceptualizing. You see, this is a direct
Yeah.
effect of gap detection on hearing. And then this is now the latent, this gap detection is a latent factor, and these are the manifest variables. So you see the difference between those two plots.
Yeah.
See that?
Yeah.
So that's a key thing from where you are. That's a key thing for you.
I see.
From where you are, that's a key thing. And I think that should be fine before you run out of all the energy.
Yeah, like yeah, you're right. I mean, I definitely need some time to digest.
Yeah.
I think at least the basic idea, I'm getting it.
Hmm.
So could you save the codes into a separate file and
Right.
pro you
Sure. Let
email
me do
it
that
to
here.
me? I mean,
Let's just do
that
that
would
now.
yeah,
No, no,
because I
no, you're
mean,
right. Let's just do that now.
yeah, if I do it
Uh,
on my own, I probably make like tons of mistakes.
yeah. So I should just save only the one for this one we've done now, isn't it?
Yeah, yeah,
This one below, I don't need to.
right. So I mean, from a 58
Uh-huh.
below, that's not irrelevant.
Yeah.
So
Yes, yes.
until 60, until
Exactly.
56.
Yeah, so those ones we just remove them.
Yeah, I think so.
Yeah. Just okay, let me do something. Something that I say you should always do. So let me take this one out. And then you should also be able to plot this. The reason I'm doing this is that in that same data, something that we should have done, which I always advise you do when you're doing any of these models, where is that data? Here. Okay. We keep forgetting, but I've said it that you should do it. So I'm just going to run this.
Oh, the bivariate plot.
Yeah, it's very helpful for you.
Yeah, I agree. Yeah. Yeah,
Because it tells you from the perspective that you don't need a statistician, you don't need anybody, you are as good as anybody. Tells you what is happening to your data. What are the relationships?
Okay.
You see that?
Yeah, in this way, yeah.
Yeah, it
Familiar
tells you
way.
that your correlation, your everything, and you can play around with them and so on. So I've left it at the bottom there. And I'll just save that. Here in simulation.
In simulation, yeah.
Yeah, come and save script. Yeah, that is it. This one is okay, but it's not really important.
Yeah, that's fine. I mean,
Yeah.
I can deal with that. It's okay.
Simulate uh, hypothesize. Yeah, you're right. Hypothesize. I think that's okay. We just can leave it.
Yeah, it's
Yeah,
fine. Yeah,
yeah, it's
like
fine.
don't worry
Yeah,
about that.
exactly. Let me go and send it to you.
Yeah,
Yeah,
yeah, you don't have to save. Yeah.
yeah, this one you don't need to worry about. So I will go and send it to you. Yeah, on the happen to the yeah, no, I'll send it to you. I'll do and send it to you.
Right.
Yeah,
Thank you.
you're
Yeah, thank you.
welcome. Otherwise, have a great day and the weekend and the rest of
Yeah,
the
you
week.
too. Definitely. You have a
Sure,
great weekend.
sure. Yeah, take care.
Yeah, see you next week,
Yeah,
probably.
sure. Yeah, yeah, probably. You will see what is happening and decide whether you want to meet or not.
Yeah, sure.
Yeah.
All right.
Okay. Yeah,
Yeah,
take
see
care.
you.
Yeah.
Take care. Bye.
Yeah. Stop sharing and